All right, we're going to talk about some other properties of exponents. First of all, let's remember this fact right here. X to the third power is called a power, x to the exponent of 3. We call that a power. The x is the base, the exponent is the 3, and it means x times x times x. All right, we're going to look at several properties. We're going to look at the product of powers. So a is a real number, m and n are integers. When you multiply powers that have the same base, that's important that they're the same base, the exponents will add. The way we write that is this. A to the m times a to the n equals a to the m plus n. Notice the exponents are adding. The reason is, let's look at an example. If you have 4 to the 6th power, that's 6 4s multiplying. And if we multiply 3 more 4s, we have 9 altogether. Those exponents add. Then let's look at the quotient of powers property. All right, so if you're going to divide powers that have the same base, again, key, same base, the exponents subtract. Now there are two ways we can write it. We can either do a to the m over a to the n equals a to the m minus n. Or, if the larger exponent is in the denominator, you can subtract and have 1 over a to the n minus m. So, notice the difference. This one, a to the m minus n. This one, 1 over a to the n minus m. So, let me do an example off to the side here. If I had 4 to the 12th power and I was dividing by 4 to the 17th power, I could make that 1 over 4 to the 17 minus 12, or 1 over 4 to the 5th. Because in the top I have 12 4s, the bottom I have 17 of them. If we expanded and canceled common factors, we'd have 5 of the 4s left over in the denominator. That's why it works. Okay, let's go back to our rules. The power of a power property. So if you have a power to a power, you multiply the exponent. So here's what we mean by a power to a power. You have a to the m raised to another power. Those exponents multiply. A to the m times n. If you write it this way, you can see the multiplication symbol. A to the m times n. So here's an example of it right there. How the exponents are multiplying. We have 6 4s. If we do that 3 times, we're going to have 18 4s altogether. That's why it's working. Okay, let's dive into the examples. So we're going to do example 3. We're going to do all 3 parts and use those properties of exponents to simplify. You can only have positive exponents in your answers. So we're going to have this one. We're multiplying when we have powers with the same base. So those exponents are going to add. So we have 3 to the 8th power. That's the product of powers property. And when we multiply 3 to the 8th power out, we get 6,561. Okay, the next example, part B. Those are the same base. They're both negative 4 to a power. That was important up here above that we had the same base as well. So we can take that and make it 1 over negative 4 to the 7 minus 2. Take the bigger power and subtract the smaller one. Leave your results in that denominator. That's 1 over negative 4 to the 5th power. If we do negative 4 to the 5th power, that's negative 1,024. Pull the negative out to the middle. It's the negative of 1 over 1,024. And there's that one. Okay, the last part, part C. This one is a power to a power. So we're going to multiply the exponents. So we have 4 times negative 3. That's going to be negative 12. So we have z to the negative 12. But remember, our answer can only have positive exponents. So we drop that z to the negative 12 down into the denominator, make it z to the 12th. And we're done.